Good morning, students. Today we are going to look at a cone. A cone is a solid shape with a vertex above a circular base. A cone has two major parts, the circular base and the curved surface. This is the curved surface. The curved surface is made from a center of a circle. This is a center of a circle. When you curve this center, it gives you a cone. Now this is a cone. You see, this is a cone. This is the circular base. This is the circular base. You can see it is a circle. Then this circle, when you curve it, it becomes a cone. Then that is why when we are looking at, you look at this cone for instance, here when it is a circle, here is called radius. But when you curve it to become a cone, you discover that this same radius has become the slant height. That's what we call here the slanting height. Then this is the circular base, the circular surface, and here you have the vertical height. That is the height from the vertex to the base. It's called the vertical height. Then we have the radius of the circle, of the circular surface. Then let's look at this. Now, when you look at a setup, now you discover that from this point A to point B, it is an arc. Then this arc, when you fold it to become a cone, that same arc AB will change to circumference. You see it in the diagram. Here is the circumference. Now we go back again to now you discover that the length of this arc AB is actually equal to the circumference AB. Now let's look at the circumference of a circle is given as theta over 360, where theta is the angle, multiplied by 2 pi r. Now that L is supposed to be r, but we call it L because when it turns to a cone, it changes to a slant height L. Now this is equal to the circle that it formed when it becomes a cone. Now this is a circular surface. Now this time is no more an arc, rather than it's not a circumference. And you know that the length of a circumference is what? 2 pi r. Now with this formula, when you divide both sides of the equation, you have r equals pi l over 360. Call that equation 1. Recall that this area of this circle is the same area that we give the curve of the cone. Therefore, since the area are equal, recall that the area of a circle is what? Theta over 360 times pi r squared. Remember that r is what we are taking as L because it's slant. Therefore, we have theta over 360 times pi l squared. Now, separate this l squared, which is 2. You put one here, you put one here. In that case, then what you now have is theta l over 360 times pi l. Recall from equation 1 that r is equals theta l over 360. Now substitute that for r, therefore you have r multiplied by pi r. What we now have is what? The curved surface area of a cone is not giving us what? Pi rl. Is that clear? You understand why the curved surface area of a cone is what? pi RL. Now let's move on to the next slide. Now we talk of the total surface area, TSA. The total surface area of a cone is given by two factors. One, the curved surface, which we have just discussed, and the circular base, which is a circle. Look at it, this is a circle. You put this circle under this, you cover it. You have the circular base, which is this, and the curved surface. Now, recall that the area of a circle is what? Pi r squared. You have seen it in the formula. Then the curved surface, we have just explained that is what? Pi r. Therefore, the total surface area of a cone is given as pi r plus pi r squared. Now, let's move ahead to, okay, before I go to the example, I don't know if any student has a question. If you have a question, please let me, yeah, and then you can send it to me through text. But please, mind you, I don't want too much video. I cannot attend to all of you on video at the same time. Try as much as possible to send text. Thank you. I'll see you in the next video.